It was June of 1944, and the skies over Soviet territory were about to witness a profound, almost unbelievable shift in power. 18 Soviet fighters, seemingly outmatched, soared against 24 formidable German aircraft. By all conventional wisdom, this should have been a massacre for the Soviets. For years, the Luftwaffe had been the undisputed master of European airspace, its seasoned pilots flying technologically advanced machines that had terrorized Allied forces from the scorching deserts of North Africa to the stormy skies over Britain. Yet, when the smoke of that fateful engagement cleared, a staggering 17 German aircraft lay destroyed or severely damaged, while the Soviets had lost only a single fighter. The weapon that achieved this impossible victory was not a marvel of complex engineering or cutting-edge systems. It was a deceptively simple aircraft, weighing a mere 5,864 pounds, nearly 1,500 pounds lighter than its German counterparts. The Yakovlev Yak-3 had arrived, not with a roar, but with a whisper of a fundamental shift in aerial combat philosophy, leaving German pilots questioning every tenet they held about air superiority. This wasn't just a new plane, it was a new paradigm, a silent revolution that would echo through the annals of military aviation. The sound of the Yak-3's VK-105PF2 engine was distinct, a higher-pitched, almost melodic note that pierced the deeper rumble of German power plants. Soviet pilots, with a touch of poetic license, described it as singing rather than roaring, a direct reflection of the aircraft's core design philosophy. While German engineers relentlessly pursued raw power and technological complexity, Soviet designer Alexander Yakovlev had chosen a radically different path. Absolute simplicity married to devastating effectiveness. The result was an aircraft that could complete a full loop in just 18 seconds, a stark contrast to the Messerschmitt Bf-109's 23 seconds. More critically, the Yak-3 could maintain its energy in sustained turns, a maneuver that caused heavier German fighters to bleed precious speed and altitude. This was far more than a marginal improvement. It was a complete paradigm shift that fundamentally altered the very nature of aerial combat on the Eastern Front. The subtle difference in engine note was a harbinger of the profound tactical disadvantage German pilots were about to face, a disadvantage born not of brute force, but of elegant, almost effortless agility. Lieutenant Sergei Lugansky, one of the first Soviet pilots to fly the Yak-3 operationally, captured this revolutionary experience in his combat diary, writing, "It's like piloting a thought. The aircraft responds before you've finished forming the intention to maneuver." This extraordinary responsiveness stemmed directly from the Yak-3's revolutionary power-to-weight ratio. Consider the Focke-Wulf 190, a formidable German fighter, which packed a massive 1,700 horsepower BMW radial engine into an airframe weighing over 7,000 pounds. In stark contrast, the Yak-3 achieved superior performance with just 1,300 horsepower driving its mere 5,864-pound airframe. The mathematics were brutally simple, yet devastatingly effective. The Soviet fighter could accelerate, climb, and turn with an agility that left German pilots struggling to adapt tactics developed for their heavier, more powerful aircraft. In the hands of a skilled pilot, the Yak-3 transcended its mechanical nature, becoming less a machine and more an extension of human will, capable of maneuvers that seemed to defy the very laws of physics, turning the sky into a canvas for its unexpected dominance. The genesis of the Yak-3's development is a masterclass in engineering pragmatism forged in the crucible of desperate necessity. In 1941, as German forces swept relentlessly across the Soviet Union, Alexander Yakovlev's design bureau faced an almost impossible challenge: to create a world-class fighter with severely limited resources. The initial Yak-1 had shown promise, but its wooden construction and underpowered engine left it outclassed by the superior German fighters. Yakovlev's team began work on an improved design, but by late 1942, the project ground to a halt. The Soviet Union simply lacked the aluminum necessary for advanced aircraft construction. Every precious pound of the metal was being diverted to the critical production of tanks and other vital war materials, leaving the aircraft designers in a desperate bind, forced to innovate or face obsolescence. The very foundation of their ambition was threatened by the harsh realities of a nation fighting for its survival, a stark reminder that even the most brilliant designs are tethered to the availability of raw materials. The breakthrough, ironically, arrived through an unlikely source: American Lend-Lease aid. While most public attention focused on the thousands of tanks, trucks, and aircraft flowing from American factories to Soviet forces, it was the raw materials that proved equally, if not more, crucial. Tons of high-grade aluminum began to arrive in Soviet ports, finally providing Yakovlev's team with the essential materials they needed to realize their vision. However, Soviet engineers did not simply copy Western designs. Instead, they took a radically different approach. They studied captured German aircraft with forensic precision, meticulously noting every unnecessary pound, every over-engineered component, every system that prioritized theoretical capability over practical effectiveness. This painstaking analysis revealed a critical flaw in the German design philosophy, a tendency towards complexity that added weight and reduced agility, a vulnerability that the Soviets were now uniquely positioned to exploit with their newfound resources. The result of this meticulous study was a design philosophy that would have seemed heretical to German engineers. Strip away everything that wasn't absolutely essential for combat effectiveness. The Yak-3's cockpit was Spartan compared to German fighters. There were no complex oxygen systems for high-altitude flight, no elaborate radio equipment, and no redundant systems that added weight without proportional benefit. Instead, every component was optimized for the specific mission profile where Soviet fighters would operate: low to medium altitude combat over the Eastern Front, typically between 6,500 and 16,400 feet. This was an enormous gamble. If German tactics evolved to exploit the Yak-3's limitations, the entire program could become a costly failure. But Yakovlev had correctly identified a critical flaw in German thinking. They were building aircraft for the war they wanted to fight, a war of technological dominance and high-altitude engagements, not the brutal close-quarters war they were actually fighting on the Eastern Front. The first combat trials of the Yak-3 began in April 1944, and the results were immediately apparent to both sides. German pilots, long accustomed to dictating the terms of engagement through superior climb rate and diving speed, suddenly found themselves facing an opponent that could match their energy in vertical maneuvers while completely outclassing them in horizontal combat. Obergefreiter Hans Mueller, a veteran Bf-109 pilot with 12 confirmed kills, described his first encounter with a Yak-3 in a letter home. The Russian fighter turned inside our formation as if we were standing still. I have never seen anything like it. It was as if the laws of physics had been suspended. This wasn't merely a new challenge, it was a fundamental disruption of their established tactical doctrine, a jarring realization that their technological edge had been blunted by an unexpected, agile adversary. The skies, once their domain, now held a new, unsettling threat. The psychological impact on the Luftwaffe was immediate and profound. German pilots who had grown accustomed to technical superiority suddenly found themselves at a disadvantage that no amount of experience could overcome. The Yak-3's ability to sustain tight turns at combat speeds meant that traditional German tactics, the high-speed diving attack followed by a zoom climb to safety, became increasingly ineffective. Soviet pilots could now force German fighters into sustained turning combat, a realm where the Yak-3's superior agility became decisively dominant. Combat reports from this period show a dramatic shift in engagement patterns. Where German fighters had previously been able to choose when and how to fight, they now found themselves reacting to Soviet initiative, constantly on the defensive. This was a bitter pill to swallow for a force that prided itself on aggression and tactical dominance, a stark reversal of fortunes that chipped away at their once unshakable confidence. The technical specifications told the story in stark, undeniable numbers. While a fully loaded Bf-109G6 weighed approximately 7,496 pounds and generated 1,475 horsepower, giving it a power-to-weight ratio of 0.197 horsepower per pound, the Yak-3 achieved a superior 0.2022 horsepower per pound with its 1,300 horsepower VK-105 PF2 engine. This seemingly small difference translated into dramatically superior performance in the critical altitude band between 6,500 and 16,400 feet, precisely where most Eastern Front combat occurred. More importantly, the Yak-3's lighter wing loading meant it could maintain lift at lower speeds, allowing Soviet pilots to force German fighters into low-speed combat where agility mattered far more than raw power. This wasn't just about speed or climb rate, it was about the fundamental physics of maneuverability, a domain where the Yak-3 had been meticulously engineered to excel, turning every turn and every climb into a decisive advantage. The true genius of the Yak-3's design became even more apparent when compared to its contemporaries in other theaters of war. In the Pacific, American pilots flying the Grumman F-6F Hellcat had achieved air superiority over the Japanese Zero through a similar philosophy, but in reverse. Where the Zero prioritized agility over protection and firepower, the Hellcat combined adequate maneuverability with superior armor, self-sealing fuel tanks, and devastating firepower. The Americans had learned to avoid the Zero's strengths while exploiting its weaknesses. The Yak-3 represented the Soviet application of this same principle to the European theater, but with a crucial difference. Rather than adding weight for protection, Soviet designers had stripped away everything unnecessary to achieve pure performance. This was a testament to understanding the specific demands of their battlefield, a tailored solution that defied universal design trends, proving that sometimes less truly is more in the brutal calculus of aerial warfare. The contrast with German design philosophy couldn't have been more stark. The Focke-Wulf 190, Germany's most advanced fighter, was a masterpiece of engineering complexity. Its BMW 801 radial engine featured sophisticated fuel injection, automatic mixture control, and advanced supercharging that allowed it to maintain power at high altitudes. The aircraft's systems were redundant and robust, designed to operate in any conditions from the Arctic Circle to North Africa. But this versatility came at a significant cost. The FY-190 weighed over 8,000 pounds fully loaded, making it a formidable opponent in high-speed combat, but increasingly vulnerable in the turning fights that Soviet pilots now sought to impose. Soviet test pilot Mikhail Gromov, who flew captured examples of both German fighters, noted the fundamental difference in his official report. The German machines are built like fine watches, precise, complex, capable of many functions. The Yak-3 is built like a sword, simple, sharp, designed for one purpose only. In the hands of a skilled warrior, the sword will always defeat the watch. This wasn't mere propaganda. It reflected a genuine understanding of how different design philosophies created different tactical realities, a profound insight into the very nature of effective military technology. The Luftwaffe's response to the Yak-3 revealed just how profoundly the new Soviet fighter had disrupted German tactical thinking. In August 1944, Oberkommando der Luftwaffe issued Tactical Directive 184, which specifically instructed German pilots to avoid combat below 16,400 feet when facing Yak-3s. This unprecedented admission of tactical inferiority sent shockwaves through the German pilot community. For 3 years, Luftwaffe doctrine had emphasized the importance of maintaining the initiative, of choosing when and where to fight. Now, for the first time, German pilots were being told to cede entire altitude bands to the enemy. The directive's impact extended far beyond mere tactical considerations. It was a psychological blow, a public acknowledgement that their once unquestioned air superiority was no longer guaranteed. This was a turning point, a moment when the hunter became the hunted, and the very foundation of German air power began to crumble under the relentless pressure of a simpler, more agile foe.